Hey everyone, welcome back to my YouTube channel, or if you haven't been here yet, welcome to my YouTube channel. Don't forget to like and subscribe, kickstarting my YouTube career here. I'd also like to sincerely apologize for the quality of this video right now. I'm recording this on my work computer, and my flashlight is giving me this great lighting right now. So we're doing the best we can though. I'm not going to film myself for most of this video. Just wanted to say hey, do my intro. This video is all about the coronavirus. Coronavirus, it's just getting real. Cardi B, if I had cool editing software, I would have put that video in there for you, but I don't have that, so you just had to get Miss W's rendition of Cardi B's coronavirus right there, so you're welcome for that. Okay, let's get started with this video all about coronavirus. So, as you can see here, I have the CDC's website of the coronavirus. So on there, they have, over here, they have the totals for every day starting from January 22nd, which is when we had our first case, all the way up to, I'm filming this on April 8th, so up through yesterday of all the numbers of the coronavirus cases. So I saw these numbers and I was like, holy cow. So we started at 1 and then got all the way up to 395,011 cases is what we had yesterday. I feel like it just came out on the news that we surpassed China, and now we're all the way up to nearly 400,000 cases, which is crazy. So I was like, okay, so something's going on here. So what I did is I kind of put this into a table. I labeled it the Rona because obviously. So I took, each date and then the number of confirmed cases on that date. This day number is kind of just like a tracker of what day it is of when the coronavirus started in the U.S. So January 22nd was day 1 of the Rona in the U.S. So there was 1 case. So then it goes all the way up through yesterday. They haven't come out with the numbers for today, and then kind of in each one, if it was important, I kind of put a little note. So March 5th was when we passed 100. So pretty much all of January and February, things kind of seemed to be under control. Then we hit March, we passed 100. Then 6 days later, we passed 1,000. And then 7 days later, we passed 10,000. And then 8 days later, we surpassed China's number and hit 100,000. Then 5 days later, we hit 200,000. 3 days later, we hit 300,000. And I'm guessing by today, we'd have 400,000 probably. So I was like, holy cow, how do we go from 1 to 400,000 in, it looks like 77 days. So what I'm going to do is I'm going to take all this and I'm actually going to create a graph out of it, see what it looks like, because I like to look at things visually sometimes, right? So insert, and I'm going to put in a scatter plot. So here's our graph of what's going on. Here it is. So it says the number of confirmed cases of COVID-19 or coronavirus. So this is what day it is, 0, 10, 20. It doesn't put the dates, but it tells you what day within the coronavirus this is. And then, right, it goes zoom, 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 straight up, right? That's kind of what happened, was it looked like everything was under control. We had 1 case, 5 cases, right? If you look at the beginning, 1 case, 2, 5, 7, 8. We stayed at 11 for quite a while, 13 for quite a while, 15 for quite a while. So we were climbing pretty slow, which is what this shows. And then all of a sudden, boom, she went fast. So this kind of graph here is very different than the graphs that we have seen so far. Right, let me open up kind of a OneNote page here. So I labeled it the Rona. So we're going to kind of see. So right, we are used to, when we're doing everything, we are used to that, right? We're used to a straight line, just even, all the way up, all the way down, even, right? Those are linear. I so apologize for my handwriting. I'm doing this all on my computer. You know, I'm doing the best I can. Right, so it's just straight linear. The line is the same the whole time, right? That's what we're used to. So this one was, oh, I forgot to click the writing tool, haha. This one had our function, right? It was mx plus b, right? That's what we're used to, that function, mx plus b. I need to get a little closer to my computer so it's easier to write. High quality content you're getting here, y'all. Right, where the m, that is your slope, and the b, that's your y-intercept, right? So the slope, right, that's how much it's climbing by each time. So with our slope, we were either adding a certain amount or subtracting a certain amount each time, right? That's how linear works. You're either adding 5 each time, adding 10 each time, subtracting 5, subtracting 10, and your y-intercept, that is where you start, right? So if we had a table, right, where you start at 0, that's your y-intercept, and then your slope is whatever you are adding to your numbers each time. So it goes 5, 10, 15, 20, right? That kind of thing. We're just adding a certain number each time. Is this how the Rona has worked? No, honey. The Rona hasn't gone up by 5 each time. It hasn't gone up by 10. It didn't go up by a steady number each time, right? If we look at it, right, looking at it, okay, we started 1 to 1, didn't go up any. Then it went up to 2, then it stayed, then it went up to 5, then 7, then 8, right? So it's going up by sometimes none, sometimes 1, sometimes 3, 2. But then we start getting over here, right? You know, February 29th, leap day hit, and it was like, shoot, we're at 24, then boom, all the way up to 30. Then that next day, 53, 80, 98, 164. So then she started going up quick, right? I don't know why I keep referring to the coronavirus as a she, but I guess it's a she. But it's going up by bigger and bigger and bigger numbers each time, right? We started just kind of climbing a little bit, staying there, climbing, staying there, and then all of a sudden it went whoop, you know, all of a sudden it got to the point, you know, that TikTok where it's like, why are we going so fast? Whoa, that's what happened. Like, all of a sudden, then it's like 100, 200, 400, 600, 900, 1,000, 200,000, 6, 1,008, 2,000, 3,000, 4,000, 7,000, 10,000, 15,000, 18,000, 24,000, 33,000, right? All of a sudden we started climbing up by ones, then tens, then hundreds, then thousands. Over here, right now we go to 24, 34, 44, 54. Now we're climbing by tens of thousands. Right? And so it's going to get to the point then where we start going up by 100,000s, 200,000s, 300,000s. That is a whole different type of graph, right? Rona, she goes like that. Like she starts out fine. We're like, okay, we can handle this. No, we cannot. That's the coronavirus. So that is called an exponential function. Okay? So those of you who did your e-learning work, this is not the first time you're seeing this word exponential. If you didn't do your e-learning, this is the first time you're seeing this word exponential. So exponential is when, like, you start kind of, like, it starts not going up by much, and then it goes faster and faster and faster and faster. Right? So the thing about linear is kind of in your table, like if you looked at your numbers, you're going by the same amount each time. You're just adding 5, adding 5, adding 5, adding 10, or subtracting either one. The thing about exponential functions is if you had a table, right, where you started, for this one, you are going to be multiplying each time. So like you start at 1, then let's say we're just going to double it each time. We're going to multiply, let's say we're going to multiply by 2 each time. We start at 1, then we double it to 2, then we go to 4, then we go to 8. right? It would keep going 16, 32, 64, 128, 256, right? We're doubling each time. So it's not just like going up by 2, right? You don't go up by 2 to get from 4 to 8, you go up by 4. So each time we're doubling it. So we're using multiplication this time to get from one number to the next number, whereas before we're using addition. So for linear, you use addition and subtraction. For exponential, we use multiplication and division. So that gives us that kind of steady go up, right? Because if you think about it, 1 to 2, all right, growing a little bit, 2 to 4, a little bit, 4 to 8, a little bit, then all of a sudden 16, 32, 64, 128, 256. It starts to climb really fast, right? So that's the difference between linear and exponential. With linear, you're just climbing by a steady amount each time. Exponential gets out of hand fast, right? That's the kind of thing that we're dealing with the coronavirus. So, right, the functions that we use for exponential is f of x equals a times b to the x. So that a is where you start. So how much you started at. The b is what you are either multiplying or dividing by each time. So it's similar to the y-intercept and slope concept, but this time it's just a little bit different. So when I created an equation, right, I made an equation for the coronavirus graph that we just got. Our equation was f of x equals 13.37, and then, 13.37 times 1.14 to the x. So there's our coronavirus equation. So that means we started at 13.37, and then we're climbing by 1.14 each time. So we're multiplying. Each time we are multiplying by 1.14, which doesn't seem like a lot because you think when you just multiply by 1, it doesn't change. But that 0.14 actually makes a big difference, right? So we think right now we have about 400,000, right? We're at day 77. So what we're going to do is we're going to take this function and we're going to see, all right, well, let's go back to my spreadsheet that I created. April 30th is the day that we're technically done with lockdown. So April 30th is day 100 of the coronavirus in the United States. So let's look and see what that would be. So we want day 100 of the coronavirus. So according to our equation, we started with 13.37. Not 100% true, but that's just kind of what the equation gave us. And we're multiplying by 1.14 100 times because we want day 100, right? So I'm going to plug this into my calculator. So we had 13.37 cases. Then we're multiplying by 1.14 to the 100th power. So that's another one of the differences is we're using exponents. We're doing it to the power of 100. So not just times 100, we're multiplying 1.14 100 times. So 1.14, 1.14, 1.14, 1.14, 100 times, and then multiplying the 3.37 onto that. Y'all, that number is actually 6,555,000. 6 million. Let me throw a comma in there so that y'all can see that. So this number with the E in it, this is what it actually means. So that means by April 30th, if we keep going at the rate we're going to end up with 6,555,600 cases. That is double the population of this whole city of Chicago. So that'd be like every single person in the city of Chicago got it times 2. So double that amount of people, right? Which is really scary. So that's why we're doing this whole social distancing thing and the lockdowns and everything, because we're trying to get that curve to hit its peak and come back down. We want this, what we have right now, we want this to be the maximum number of people that have it. So that's what this whole social distancing thing is about. So I hope you guys enjoyed this video of kind of learning a little bit more about the coronavirus. This isn't the end of the of what we're going to talk about of it, but this is going to be the end of the video for today. I hope you guys enjoyed it. This video only lets me record for 15 minutes, so I have a couple seconds. I love you guys. I miss you guys. Enjoy this video. Look forward to the next one.